Okay, ladies and gentlemen, let's look at the circuit. Now the circuit is connected an accumulator of 2 watt connect through the wire, resistant wire of AB with length 100 cm. Okay, sorry. Better, yeah, I need to restart the. Okay, so from here, what happened is this dry cell will connected to a resistant wire along AB through a rheostat. And we also connected it with this one, okay, E1 and E2, different source of the, what's that, the battery. So now, once I connected, I need to find out, okay, we need to move until the current back, the galvanometer show that the reading is 0. Okay, now we notice that the current, you will notice that the pointer of the galvanometer is 0 at 60 cm. Okay, that means that left side is 60, right side will be 40 cm. Okay, now if I replace with another cell, we move until I get the reading is at the 5.6. You notice or not? At the 5.6. So as a conclusion, the difference, right? There is a difference, right? Actually, it's like that. For the standard cell of EMF is 1.01, around E1 is around 1.01 at watt. Balance length is 60 cm. So hence E1 is directly proportional to 60 cm. It's directly proportional to the length. For the cell of EMF, balance length is longer, right? At the 5.6, correct or not? That means that E2 also directly proportional to the length. That means that the E2 will be greater than E1. So the ratio of the E2 over E1. Okay, the ratio of the E2 over E1 is equal to 85.6 over 60 times with 1.01 at watt. 1.01 at watt is come from where? It's come from the wet accumulator of 2 watt. Okay, if we get the 2 watt, that means that it will be around, for example, that this normally E1 they given. That means that we know that it's around 1.01 at watt. So that means we use it to determine the E2. That means that this one, the E2, okay, E2 is 1.45 watt. So that means that what is the conclusion? So this 2 watt is used to provide the current. Provide the current to the circuit. Once I use the E1, that means that we should place a non-potential difference, a non-EMF. That means that I know that this voltage is 1.0 something, but this voltage must lower than the 2 watt, never higher than 2 watt. That means that any battery source with non-potential difference, non-EMF, I make sure it's 60. After that, I replace with unknown batteries or unknown accumulator. A source with unknown EMF or voltage, then I make sure again I get at the 5.6. So we use the formula E2 over E1, the ratio of, we can use the potential meter as a voltmeter to determine an unknown battery. Next. A circuit is connected. A battery is connected to the voltmeter. That means that show that is the EMF, right? EMF is equal to 1.5 volt. Once I connect a rheostat along the point PQ, that means that found that the reading reduced to 1.2 volt. 1.2 volt means that is the potential difference. EMF still is 1.5. Now, if I connect the, let's say, determine the internal resistance. Okay, now if we wish to find out the internal resistance, this means we can use the concept of battery connected to a rheostat and also parallel connection to the voltmeter. So the concept, same thing, I can convert it. I can convert it into a potential meter. We can connect as shown in the diagram. So same thing, the battery connect to a wire of 100 cm length through a rheostat to set a constant voltage, constant current, and then connect to another rheostat. Now, what we can do, we switch on, we find out the balance. The balance is 66.7 cm. That means that the battery, this is the battery, right? Okay, the voltage of the battery is balanced at 66.7 cm. Next, once I put another switch, that means that we find again the distance will be reduced. That means that 66.7 will be the length. We get the voltage. Once we get the voltage, this will be the EMF of this battery. When I connected, that means that 50.8 will be the potential difference across the rheostat. E is directly proportional to L1. So EMF is directly proportional. EMF is 66.7. Okay. And the L2, the potential difference is directly proportional to the L2, 50.8 cm. So E over V is equal to the potential ratio of the potential EMF over the potential difference is equal to L1 over L2. Okay, which is equal to R plus R over R. So we get that from here, the R is 5 ohm. That means that from here, the R is 5 ohm. Where is the 5 ohm? You notice or not? R is 5 ohm, right? Okay, they told us the resistor is 5 ohm. So we use R is equal to 5 ohm, replace into the formula. L1 over L2 is equal to R plus R. Okay, R, the resistance of resistor plus with the internal resistance over the R. Okay, so we get that the internal resistance will be 1.56 ohm. Okay, so that means that we use the formula EMF over the potential difference will be the L1 length of the EMF over length of the potential difference. Okay, and it will be R plus R over R. So at the end, we get that the internal resistance is 1.56 ohm. Next, notice that V1 equal to I1 R1, V2 equal to I2 R2. V1 over V2, this means it will be I R1 over I R2. As a result, V1 over V2 actually is equal to R1 over R2. Why? The reason? Because the V1 is directly proportional to R1. V2 is directly proportional to R2, where the V1 plus V2 is equal to the EMF. Let's go to the next slide. Now, just now we compare, right? Okay. So now we connected the resistor in series. So now we observe what happened. Just if I put the connection of the wire here, that means that the current just flow through R1 and go to the galvanometer, jockey, and balance. This means R2 without any current potential. So this means that first, find out the balance point. The balance point is 55.6. Okay, if this just pass through, okay, now this means that the current pass through the R2 only without pass through the R1. So what we get is 34.8. Just now pass through I1 only, now pass through the V2 only. As a conclusion, L1 is equal to 55.6, L2 equal to 34.8. So IR1 V1 over V2 is equal to L1 over L2. As a conclusion, we get that R1, okay, we cancel the I, we get that the I cancel, yeah, okay, we cancel the I, then R1 over R2 equal to 55.6 over 34.8, we get that is 1.6. The ratio is 1.6. Where the R1 is 2 ohm, then we get that R2 is 1.25 ohm. Okay, we notice that R1 and R2. If R1, that's mean connection like that. R2, connection like that. Okay, if they give us R1, they must give one of the reading. Okay, they give one of the reading is R1 is equal to how much? The R1 give is equal to 2 ohm. So how about the R2? That means we use it to find we use to determine the resistance of another unknown resistor. Okay. Next slide. Okay. So how about the next slide? Later, you're still in loading. Okay, as a conclusion, the potential meter is used to determine the EMF and EMF of a cell, and also determine the internal resistance of a cell, and finally to compare the resistance. That are the function of the potentiometer. Now let's look at the circuit. So the weight cell of 2-watt accumulator is connected to a battery. So we find out the reading. None of the reading. None of the zero reading obtained for the galvanometer. So what we need to do, what we can do, if I reverse, we notice that also now if I reverse, I notice that there is a 75 cm, right? So this means that just now the connection is, the terminal is reversed. So this means that positive should be connected to positive terminal so that most of the current flow through. But now since this one is in series, okay, so none of the reading obtained. So we must positive terminal and to the positive terminal and negative terminal to the negative terminal. The first problem. Second problem. Now, once we connect, is it possible to find it? No. But now we notice that positive terminal, the battery, no problem. Okay, the terminal of the battery are correct. So what we need to do is, we do nothing, we move along, we still cannot obtain the 0 point. So what we can do, we adjust the rheostat until we get a reading. Almost the perfect one is 40, 60 or 60. You get 60, 40. Okay, almost the perfect one. Okay, it's 50, 50. That's me actually. Okay, nothing to compare. Okay, next problem is now we connect to another non-source, unknown source. So we get that the reading is 5 cm, right? 5 cm and 95 cm. Okay, very big difference. So what we can do, we slightly adjust the rheostat so that we get the reading now almost 45 with 45. Okay, that means we 45 with 55. Okay, that means that almost equal, but not exactly equal. Yeah. Okay, almost equal balance. And next, we can set that when a balance point is not obtained, the possible faults are maybe the cell is in the circuit are connected wrongly, wrong terminal. Second, the potential drop across the slide wire is too small to balance the voltage being measured. Okay, so what we need to do, we try to adjust the rheostat to obtain the reading. Okay, so ladies and gentlemen, that's all for today's lesson, and I will post the question for today's lesson through the Telegram. So I want you all do the question before check the answer. So this is the question of today's lesson. Question for the potentiometer. We have question 1, question 2, question 3, question 4, longer a bit, question here, question 5, question 6, and also question 7 will be the last one. Okay, so that's all for today's lesson. So I hope you do the question after the lessons. Thank you very much and see you on next lesson. OK, so 看一下谁没有到，16位、15位，那么是永乐有到吗？永乐有在吗？永乐昨天睡迟，没有进到第一堂课，今天也没有到哈。所以是永乐不在，跟 Kelvin Pang。OK， 其他的都有在了。
老师我在。
哎，你在哦，永乐哦，这样是谁没有在？
有。
谁没有在 ？check 一下。沈婷有在，夫有在。女生有全部在吗 ？OK，Silky。OK， 好了，那么 Silky 一个没有在，没关系，这样等一下我再看 Silky 有什么有进吗？有进提醒他一下 ，Mr. Lin 念他一下。OK， 好了，那么今天我们的课就上到这边。OK， 那么我们明天再接下去。OK，so thank you very much and see you tomorrow.
谢谢老师。
OK，bye，see you.
Thank you, Mr. Lee.
You're welcome. See you.